This video, we're going to talk about minimizing the surface area of a square-based prism. So we're not talking about all prisms, just ones that have square bases. So this one looks like it might be square base, maybe this one, but this one is not. So square-based prism is what we're focusing on today. Why would package designers want to minimize the area of a box or a container? Why would they want their boxes to be use the minimal surface area, the minimal amount of cardboard? They can save costs or expenses if they can find the smallest amount of packaging to contain a product. If they can get a box to be the right size but contain exactly the volume that it needs to contain, then they can save money on their packaging. So we've got those are all different prisms. A square-based prism will have a minimum surface area when the prism is a what? So we've already talked about this. So when the prism is a specific kind of prism, when the box is a specific shape of box, we will have a minimum surface area. Do you remember what that is? When it's a cube, so when we have a cube shape, if we can create a cube shape, we're always going to get the least amount of surface area. So why is it that very few boxes that we see are cube shaped? And there's other reasons for that, and that comes with the ability to stack them well on shelves at the stores. If everything is in a cube shape, it's harder to stack it. And look at all of this decoration you can get on the front. If you have a big front face of your box, you can get a lot of stuff on there. If you have a smaller one, because it's a cube, a smaller surface area, then you can't get as much attention-grabbing information on there. Each of these square-based prisms has a volume of 64 centimeters cubed. So volume is always cubed. Find the height of each prism. That's what the first question is asking. So there's our three prisms. We're going to do each one. So I'm just going to kind of write them below those titles there. The first question is asking for the height of each prism. So we need the volume. The volume is area of the base times the height. Volume is length times width times height of a prism. But in this case, our base, the length and width, which are the base, are the same because we're only doing square-based prisms. So the area of the base is really, you're finding the area of the bottom square, and then you're going to multiply that by the height. So we can put b squared. We also know what the volume is. The volume is 64 cubic centimeters, so I can sub that in for v. My base is b squared. You could use L squared if you wanted to, or W squared. Or your bottom dimension is the same. So for prism A, the volume is 64. Well, they're all 64, but the base is 2 by 2. Each of these two sides is 2. So we're going to do 2 by 2 times the height. So 2 times 2 times the height has to equal 64. That means 2 squared is 4. So I need to isolate h now. I'm going to divide both sides by 4, and I get 16 for h. So the height of prism A is 16. So I can put that in there. This one would have to be 16 centimeters. The first one. What about prism B? So prism B, we know for prism B that each side is a square, so that means this side is equal to this side, and they're both 4. So the area of the base is going to be 4 times 4, that's 4 squared. So we have 64 equals 16 times h. Now I need to isolate h, and I get 4 equals h. So in this case, the height of the prism is 4 centimeters. So this is a 4 here as well. Turns out to be the same as the other ones. This is also 4 centimeters. Well, I want you to press pause right now and do prism C yourself. Follow what I did for prism A and prism B, and do prism C. Okay, hopefully you took a minute to do that. We start off with the formula, and we already know volume, so we put 64 in there, and prism C has a base of 8 by 8, so there's our 8 squared. That's 64, so we divide both sides by 64, and we get 1 for the height. The height of prism C is 1 centimeter. That's very flat. That's part A. Find the height of each prism. part B, find the surface area of each prism. So again, we'll get our three, we'll work our answers down below here, each three of them. So what should we do first for the surface area? We're looking for the surface area. Remember what the surface area means? It means it's the sum of all the areas of all 6 faces. So for this tall one here, I would need this face and then the 2 are on the back and the top and the bottom. I need all 6 faces added up. I need the sum of them. But the thing is, for a prism, the top and the bottom are the same. So I need the area of the top and the bottom. I can figure that out. And then I have 4 sides. They're all the same on a prism. All 4 sides are exactly the same. So I can simplify this formula to write, I have 2. This is my bottom pieces. The length and the width are the bottom. So this, in this case, 4 by 4, that would be my bottom. And then the length times the height gives me the 4 sides. So to get this side here that I'm kind of highlighting, this would be 2 by 16, and I have 4 faces that are 2 by 16. So for prism A, let me erase this one I put here. For prism A, we're substituting into the formula. This 2 is this 2. The length and the width are the bottom. Each bottom side is 2 by 2. And now we have the 4 sides, so there's 4 times, and 2 against this side, and then 16 is my height. So 16 I got from down here. That's where the 16 is coming from. Simplifying that, I do the brackets first with multiplication, and now I'm going to continue multiplying the terms with the brackets. And addition gives me 136 centimeters squared. So that's the surface area of prism A. Let's look at prism B. Remember the formula. This is our formula here. We've got 2L times W. So what's the length and the width, or what's the base parts? So this one, there's a 4 and a 4. Those are length and our width. And then when we get here for the height, that's this 4 right here. So we're sub all those numbers in there. The height comes from down here. We figured out the height would be 4, so I put that in red. Now we do some multiplication of the brackets. And then we do further multiplication, add those together, and we get 96 centimeters squared. Centimeters squared because it's surface area, it's not volume. So now again, prism C, I want you to do this one on your own. Press pause, follow the formula that we did to find the surface area of prism C. Okay, I'm going to assume you took a minute to do that. We substitute into the formula. You got your height from down here. We got the height to be 1 down here. Substitute that in. Then we do some multiplication and some addition, and we get 160 centimeters squared for prism C. It's important, you would have heard me say this before, that you don't memorize formulas. Like don't try to memorize all this stuff here. As soon as you see a question that asks you for the surface area, you need to know that means the area of all of the surfaces or all of the faces. And then you can come up with a formula like this on your own, right? You've got a top and a bottom which are the same. You've got 4 sides which are the same. So you can come up with your own formula rather than just trying to memorize all the time. Part C says order the prisms from least to greatest surface area. So this is the easiest part, least to greatest. Remember that all boxes or prisms contain the same volume. That was up here. So they all hold 64 centimeters cubed of volume, of space, of material. So their surface areas from least to greatest. They all have the same volume. So each of these 3 boxes could hold exactly the same amount of sand, say, right? Or cereal. They would all hold the exact same amount. And the one that has the least surface area, that's the one that has the least surface area is the one that's going to be cheapest for me to produce if I'm the one in charge of packaging. And that is the cube. The cube is the least with 96, but as I said, you will rarely see companies use this shape because you don't have as much facing the customer when they're looking around and you're trying to grab their eye. If you just have a small surface area facing them because of the way it's stacked, then you're not getting a lot of mileage off of your box. The next smallest one was a tall one, was 136, this one right here, so that was the next one. And the one that had the most surface area that would cost me the most to use would be the flat one. So you would never see anything like this, quite flat like this. But somewhere in between is what we see most often. We don't ever see a cube, and unless it's like a CD or something that's really small, or pizza that needs to come in a box like this, you don't usually see a box like that either. So minimizing surface area is important because it helps us to reduce costs of production. However, there's usually other factors involved for reasons why people don't minimize the surface area. Our second example, we have a square-based prism. Everything today, that's their title. Square-based prism is on your title. We have a square-based prism, and again, we're given the volume. It's 512 cubic centimeters. What are the possible whole number dimensions of the prism? Whole number means no fractions. There are always different ways to solve a problem, and when you're thinking about this right now, which I hope you're doing, you're not just waiting for me to tell you what to do, there's a couple of ways you could do it. Some of you might be thinking kind of use a chart, come up with some numbers with a chart. Some of you might be wanting to draw, kind of sketch out a bunch of different prisms and put their dimensions on them. Maybe some of you are thinking about a formula that will work, that will make it easier. Let's try a few of these. First of all, if the prism is a cube, and we've already talked about it, a cube is good because a cube is going to minimize our surface area. If the prism that we have to deal with is a cube, then the formula is going to be side times side. Every dimension is called S or L or W, whatever you want, but there's 3 of them. So the volume is S cubed if the prism is a cube. So in this case, the volume 512 would be S cubed. Now, how could we figure out the side length from that? So you need to look at your calculator. You should have something that's called a third root button. It might look like this on your calculator, a little 3 inside of a square root, like this, something like that. There might be an X in here or something. Probably, if you have a scientific calculator, you quite likely have that button. So what we're going to do right here is I'm going to I want to isolate S. I need to get rid of that 3. To get rid of that 3, I'm going to take the cube root of both sides. So it's like taking the square root, but it's a cube root. So I'm just going to draw it in here. I'm going to take the cubed root of S cubed. Those 3's will cancel each other out and leave me with an S. But then I also have to take the cubed root of 512. So that button on your calculator, if you use it, is going to tell you what number multiplied by itself 3 times is 512. And the answer that your calculator should give you is 8. So if you do 8 times 8 times 8, you're going to get 512. So if we are looking, that's one possibility for our option. One possibility for our box is that each side is 8. The question said the dimensions, so I would say in this case, therefore, length, width, and height could all be 8 centimeters. That's one possibility. Length, width, and height could all be 8 centimeters. That's only one option. The question wants to know what are the possible whole number dimensions. That's one possibility. We've got 8 by 8 by 8, and that's only if it's a cube. And that will minimize our surface area, so it's an important one, but the question wants to know if there's any, is asking for all the whole number of dimensions. So what else do we need to think about? If the prism is not a cube, then our formula for volume is length times width times height. And we're given the volume. We're talking about volume here. That's why we're using this formula. So if it's not a cube, then we're just doing length times width times height. But if we have this, if you reread the question again and the title, it's square-based. If it's square-based prism, so the bottom of this is a square and the top is a square, then the length and the width will be equal. So our height is separate, but length and width, because it's square-based, length and width are the same. Since the prism has a square base, then the length will equal the width, so we could write the formula like this. 512 equals L squared times H. And you could, I used L twice because length and width are the same, but you could have used W squared, or you could have used B squared. Sometimes you'll see B for base. Or or S like we had over here for side squared. So we have this formula that's a little bit different than the formula that we had here because we're not talking about a cube this time. So here's one way to do this question. We could set all these dimensions up in a chart. We've used charts before. So we may need more rows in this, we may not even need 4, but these are just the Prism numbers that we're going to have, length, width, and height. But I'm going to put in here, length is equal to width, right? These two are equal to each other. Length and width have to be equal to each other. To get the volume formula, I'll put it over here. The volume formula is going to be L squared times H. That's our volume formula. All right, so what if we had let's start at the bottom. What if we had a length and width, meaning these bottom numbers, I'm drawing them on the blue prism here. If they're both 1, let's start with a 1. If the length is 1 and the width is 1, remember they have to be equal. What would the height be? So if the volume is 512, and I know that length times width times height has to equal 512, what I've got now is 1 times something is 512. Well, that's obviously got to be 512, right? 1 times 512. So I could have these dimensions, a length of 1, a width of 1, and a height of 512. So that would be like a really tall, skinny one there. Let's do a 1 and another 1. Whoa, this is not a good example, but I'm just trying to draw a really tall, skinny box here. There we go. That could be your 1 by 1 by 512. That's what it would look like, 1 by 1. So what other options have we got? Let's go to 2. What if your length is 2? That means your width also has to be 2. So that times what is 512. So these two together give me a 4. So I've really got 4 times my height has to be 512. How can I figure out the height? How can I figure out that question mark? I'm going to divide both sides by 4. And that will give me a value for my height. So we get 128. So let me erase all this and put in 128. So there's another option, which would be a lot shorter than this one, right? A much smaller box. Next, how about 3? 3 by 3, these two have to be the same. 3 times 3 times what is 512? So 3 times 3 times what is 512? Or 9 times h is 512. So you need to get out your calculator, divide both sides by 9. So what'd you get? You probably got something like 56.888888 repeating. But remember the question way up here, look at the question, it says whole number dimensions, so we can't use 3. So we gotta erase the 3. So this one didn't work. 3 was no good. So let's try 4. See what happens when we try 4. 4 by 4. That means 4 times the height has to equal 512. 16h equals 512. Divide both sides by 16. Is that one going to work? You betcha. That gives us a 32. Now these numbers are getting closer and closer together. So look how 1s and 512, that was pretty far apart, right? That was this long, skinny one. 2 by 2 by 128, that would mean our dimensions are getting a little closer. This is a little bit bigger box maybe. 4 by 4 by 32, so this is getting even tighter together. It's getting closer and closer to our cube here. What other dimensions do we have? So try 5. Does 5 work? If we have a length and a width, they have to be the same, length and width of 5. can we get 512 with a whole value for the height, a whole number value? So 5 does not work. What about 6? We know one that does work. We did get the 8 to work. We could put that in, but we need to see if there's any more. Hopefully what you see is a bit of a pattern emerging. Now, continuing to do what we're doing with the chart, which is trial and error, is perfectly legitimate. You keep doing we tried 5, then 6, then 7. Now we know 8's going to work. So we could keep doing this trial and error. There are other strategies though, and maybe what you've noticed is we're doing a little bit of algebra here each time when we're doing our calculation. So I'm going to look up at my equation here. The algebraic calculation that we're doing is we're looking for the h all the time. We're trying to isolate h, which means we're dividing both of these by the L squared. And we're getting this formula, which is 512 over L squared equals h. Now it's a little faster to sub into this formula and see if you can find a whole value for h by subbing in. So just going right to the formula. So if you're doing the 5, you would sub in 5 squared. So you'd be doing 512 divided by 25. No good. And then your next one, if you're doing the 6, would be 512 divided by 36. And that's also no good. So we do 512 divided by 49. So again, I hope you're maybe seeing another pattern here. And the other pattern is that these numbers, of course, are all perfect squares because we're squaring them. So if you know your perfect square numbers, all you really need to be doing right now is 512 divided by perfect square numbers, and then perfect square numbers. And you're going to go through, you can go through your list that way as well till you find more numbers. Now I'm going to add 8 in here because we know we already got this one, 8 by 8 by 8. So there's one more. When you're dividing by perfect square numbers, once you figure out the perfect square number, well, then you'll back it up to figure out what the length and the height are. So work on that and see if you can find one more, and press pause while you just work that out on your calculator, and then I'll put it on the chart here. Did you find it? So we found a 5th prism here, I hope, which is 16 by 16 by 2. That's also equal to 512 for volume centimeters cubed. Another way you could have tried to do this problem is, instead of starting with these numbers here, which are equal to each other, you could have started with height values. You could have started subbing in for height value of 1, sub in a height value of 1, and then work backwards to see if you can get a length and a width that way too. So you could have done that. This way maybe is a little more straightforward because you're getting 2 of your dimensions taken care of right away if you can figure these ones out. The chart method doesn't have to be the way you do it. You can come up with a formula, and you can draw diagrams to help you see what they would look like, but just remember the question said it was whole number dimensions, so we're pretty limited there. That's all there is to today's topic on minimizing the surface area of a square-based prism. So the next step, and what you have to do in your homework, is you have all of these all have the same volume. They all have a volume of 512, but they will all have different surface areas because they're all different boxes. And you would be investigating a bit with those surface areas. That's it.